We're going to start this lesson off with a definition of what a one-to-one function is. And so it says a function is one-to-one if any two different inputs in the domain correspond to two different outputs in the range. And so after reading that definition, you were probably asking, okay, so what does that mean? So let's break down that definition. For it to be a one-to-one function, first and foremost, it must be a function. And so we went over a function at the very beginning of this class in Module 1, Lesson 1. We had a definition that said for every x value, there exists a unique y value. So what that meant is that our x values could not repeat, right? If you remember, we kind of said x can't repeat or x can't cheat. When we look at a graph, what that meant is it must pass the vertical line test. So first and foremost, it must be a function. So now getting more into that definition, for every y value, there exists a unique x value. So now my y values also can't repeat. And when we are looking at the graph, now it must pass the horizontal line test. So here's our first example. Example 1, determine whether the following functions are one-to-one. So in this first one, I just think this is a funny example. The domain are our list of guys, and our range are our list of girls. And so you can see we have one line going from Bob, Dave, John, and Chuck. So it is a function. But it already told me that, right? So determine whether the following functions are one-to-one. So we already knew that our x didn't repeat. So what we're looking for is, does our y repeat? Well, we have one line going to Carla, one line going to Deborah, but we have two lines here going to Phoebe. So since Phoebe is repeating because she is dating both John and Chuck, since we have repeating y values, that means that this is not one-to-one. Part B, we now have a set of ordered pairs. So again, it's already a function, but we can look, our x is -3, -2, -1, 0, and 2. So the x doesn't repeat. So what we are now looking at are all of these y's. Do I have a y value that ever repeats? And the answer is no. So because we have now no repeating y values, that means that this is yes, one-to-one. So this is how we can tell if it is a one-to-one function when I am given either mapping or ordered pairs. But more times than not, we're going to be given a graph. And so when we are given a graph, to be able to test if our function is one-to-one, we are going to use the horizontal line test, or our HLT. And it states for every horizontal line intersects the graph of a function and at most one point, then the graph is one-to-one. So example 2 says for each function, use its graph to determine whether the function is one-to-one. So the first thing that we have, let me get some different color pens out here. The first thing that we have is f of x equals x squared. So we have dealt with this graph and this kind of function quite a bit. So hopefully we know that our x squared is a parabola. And if we have just x squared, it means it's not being shifted up, down, left, or right. It's not getting compressed or stretched. It's not being reflected. So this is just your most basic U-shape parabola. Now, it already tells me it's a function, and you can test that. Anywhere you put a vertical line, it only crosses one time. But does it pass the horizontal line test? No, it does not, because it intersects twice. So this doesn't pass the HLT. So therefore, this is not one-to-one. Okay, now we have an x cubed. And for x cubed, hopefully we remember that from our key graph because we haven't dealt too much with them up until this point. We will deal with a lot more x cubes when we get to module 4. But this one is kind of our S curve right there. Okay, so again, we can tell that it passes the vertical line test, but does this pass the horizontal line test? And anywhere we put a horizontal line, it intersects this graph in one spot. So this one passes the HLT. So therefore, yes, this is 1 to 1. Now I do want to make note, because this is simply x cubed, this one does work, but not every x cubed is going to work. Sometimes these little curves here can get more dramatic and can be something more like this right here. And that one does not pass the horizontal line test. So what I would suggest, unless it's one of these most basic key graphs, put this in your graphing calculator to get a good graph representation of this graph.